All right. What we're going to do right now is we're going to kind of go over a few special right triangle problems. And what I want to kind of do is actually connect special right triangles with the concept of similarity. So this is special right triangles. And what special right triangles do is they give us kind of a technique to be able to solve right triangle problems where maybe the Pythagorean theorem does not quite work. So there's two types of special right triangles. It is always important when you are doing special right triangles that you are using what we call the reference triangle. So what this means is we need to kind of like build our examples off of like the basic type of triangle that it is. So we could say, for instance, that all 45, 45, 90, and what I mean by that are degree angles, right triangles, are similar to what we call the unit triangle or the standard triangle or the reference triangle. So for instance, if I have legs that have a measurement of 1, and here's my 45, 45, 90 for my angles, then the hypotenuse would be square root of 2. And we also have, as the other type of special right triangles, a 30, 60, 90. So what this means is that all 30, 60, 90 right triangles are similar to so this short leg would be 1. The hypotenuse is twice as big. As the shortest side. And then our longer leg is square root of 3 times as big. So that's a number that's like 1.73. Now, the reference triangle would just have side length of 1, square root of 3, and 2. So the good news is that all 45, 45, 90 triangles are similar to the 1, 1 square root of 2. And all 30, 60, 90 triangles are similar to the 1, 2 square root of 3 triangle. So let's actually look at a few delta math examples. So we're going to kind of start with a basic one, and then we're going to kind of work our way up to what a more difficult one looks like. All right, so this is kind of a pretty basic one here. We have a 45, 45, 90 triangle here. So that's the first thing that I like to do. I like to kind of classify what it is. So 45, 45, 90. And I like to draw my reference triangle. So I'm going to draw the most basic 45, 45, 90. And that is a 1, 1 square root of 2. Now, the mental math solver would actually make an observation and say, my legs are congruent. So if this is 1 and that is 1, and this is square root of 3, then x also has to be square root of 3. Now, some people are naturally good at special right triangles. Now, if you're not sort of that person, I recommend that you kind of treat this like similar triangles. So what I'm going to do is I'm going to compare the black triangle with the red triangle. So I'm just going to do black over red, and I need to solve for x, and the side from the black triangle that matches with the red triangle is 1. So that creates a ratio, and I used a circle to kind of designate those corresponding sides. Now, the other side is square root of 3, and I'm choosing this because, you know, it's part of my black triangle. And the side that matches with that side from the red triangle is 1. And if I just cross multiply and kind of treat this like a beginning of a chapter 8 problem, I get square root of 3 equals x. And this one I would say is, you know, going to be one of your easier ones because we are given the leg, and then we just put square root of 3 in. And what I would encourage you to do is, as you are working through Delta Math, I think it is important to look at the 2 triangles that Delta Math has chosen to look at. So there's the problem that is assigned to you and the standard or the reference triangle. The reference triangle for a 45, 45, 90 is always the same. So for all 45, 45, 90s, you're going to have 1, 1, square root of 2. One of the ways that you can immediately tell if you are getting the concept is looking at the proportions. You should be making it a goal that you should be getting a similar proportion, you know, when you are cross multiplying things. Okay, let's take a look at another example here. Now, this one is a harder example because we do not give you the shortest side. But what we are going to do is we're going to draw the reference triangle. So this is a 30, 60, 90. And I'm going to make sure that I draw kind of a version that is rotated in the same way. So my shortest side is 1. My hypotenuse is going to be 2. And then my longer leg is going to be square root of 3. And I'm going to do, you know, black triangle to red triangle. So my black, I need to solve for x. So I'm going to circle that, and I'm going to put a circle on the side that corresponds to that. So I'm going to have x over square root of 3. And then I have a square root of 2, and that's part of my black triangle. And then I have a 2 that corresponds to that. And I'm going to want to cross multiply. So when I cross multiply, I get 2x equals to square root of 3 times square root of 2. And when you have radicals, you just need to multiply what's inside. So I got square root of 6. And then I'm just going to divide by 2. So I'm going to get square root of 6 over 2. And sometimes you have a radical that you can simplify. Sometimes, like with square root of 6, that is broken down as much as it can be. So I'm just going to do square root of 6 divided by 2. And we're good. Now, one thing that they kind of do in Delta Math may be a little different than I do. They compare larger leg to hypotenuse, and they compare larger leg to hypotenuse in the other triangle. I just like to kind of like break it down into a similar triangle problem like what you did in earlier chapter 8. All right, let's do one more. I'm choosing one that, okay, this is a good one. So this is find the x side in simplest radical form with a rational denominator. This is a 30, 60, 90. So you're going to want to label this 1, 2, square root of 3. And like before, I'm going to do black over red triangle. So the x and v2 match up. So that forms a ratio. And then v2 is from my black, and the square root of 3 is from my red. So I'm actually going to cross multiply. So I get 4 is equal to x times square root of 3. And I'm going to show you something funny that happens. So I have x equals to 4 over square root of 3. And I'm going to try and see what happens. And it actually marked me wrong. Now, one way that I can tell that I got the geometry right, at least, is that I actually got 4 over square root of 3 as kind of an intermediate step. And if this was the only thing that you did, I'd go, 3.5 out of 4. Now, what you had to do is get the radical out of the denominator. So to get it kind of in its proper form, I'm just going to kind of like illustrate the steps here in the process. I got 4 over square root of 3. And one thing that I can do is I can multiply the denominator by square root of 3. So I can get rid of the square root in the denominator. And if I'm doing that in the denominator, I also have to do that in the numerator. So I have 4 square root of 3 over 3. And then that would be your final answer. So watch out on kind of those trickier examples that you are getting rid of your radicals in the denominator.